Safranin is a biological stain used in histology and cytology. Safranin is used as a counterstain in some staining protocols, coloring all cell nuclei red. This is the classic counterstain in both gram stains and endospore staining. It can also be used for the detection of cartilage, mucin, and mast cell granules. Safranin typically has a chemical structure shown at right. There is also trimethylsafranin, which has an added methyl group in the ortho position of the lower ring. Both compounds behave essentially identically in biological staining applications, and most manufacturers of safranin do not distinguish between the two. Commercial safranin preparations often contain a blend of both types. Safranin is also used as redox indicator in analytical chemistry. Safranines are the azonium compounds of symmetrical 2,8-dimethyl-3,7-diaminophenazine. They are obtained by the joint oxidation of one molecule of a paradiamine with two molecules of a primary amine, by the condensation of para-aminoazo compounds with primary amines, and by the action of para-nitrosodialkylanilines with secondary bases such as diphenylmetaphenylenediamine. They are crystalline solids showing a characteristic green metallic luster. They are readily soluble in water and dye blue or violet. They are strong bases and form stable monacid salts. Their alcoholic solution shows a yellow-red fluorescence. Phenasafranin is not very stable in the free state. Its chloride forms green plates. It can be readily diazotized, and the diazonium salt when boiled with alcohol yields aposafranin, a benzene and ulin, C18H12N3. Kerman showed that aposafranin could be diazotized in the presence of cold concentrated sulfuric acid, and the diazonium salt on boiling with alcohol yielded phenylphenazonium salts. Aposafranin, C18H12N2O, is formed by heating aposafranin with concentrated hydrochloric acid. These three compounds are perhaps to be represented as ortho or as paraquinones. The safranin of commerce is an orthotolysafranin, the first aniline dyestuff to be prepared on a manufacturing scale was morvain, which was obtained by Sir William Henry Perkin by heating crude aniline with potassium bichromate and sulfuric acid. Morvain was converted to parasafranin by Perkin in 1878 by oxidative reductive loss of the 7N-paratoluol group. Another well-known safranin is phenasafranin, widely used as histological dye, photosensitizer and redox probe.